Welcome to the video lecture series Digital Filter Design and its Application. My name is Dr. Anilesh De, Associate Professor, Department of Electronics and Communication Engineering, Narula Institute of Technology, sharing the course with one of the renowned professors, Professor Dr. Sholil Kumar Sharnal. Professor Dr. Sholil Kumar Sharnal, retired professor and head, Department of Electronics and Telecommunication Engineering, Jadavpur University. Presently, Professor Dr. Sholil Kumar Sharnal working as a professor, Department of Electronics and Communication Engineering, Narula Institute of Technology. This course is basically designed for the MTech in Electronics and Communication Engineering students. This is lecture 1. In this lecture 1, I discuss the very basic concept of signal systems, continuous and discrete time signals, continuous and discrete time systems, impulse response and convolution sum. First I go, what is signal? The variation of any physical quantity with any single or multiple quantities of independent variables is called signal. If I write y equals to xt is a signal. There are two variables y and t. Y depends on t, so y is dependent variable and t is independent variable. As per the definition, variation of any physical quantity. So example of the physical quantities are voltage, pressure, temperature, etc. with any single or multiple quantities of independent variables. Now, number of independent variables determine the dimension of the signal. If there is one independent variable, the signal is one dimension signal. Example of the one dimensional signal is speech signal. When the independent variables are 2, it is a two-dimensional signal. Example of two-dimensional signal is image. When the independent variables are 3, that is a three-dimensional signal, and example is video. Now this is one sine wave. Y-axis is denoted by Vt, x-axis is denoted by t. And this is the continuous time signal. In nature, all signals are analog signals, and analog signals are continuous in time. Now I discuss continuous time signal and discrete time signal. In the previous slide, I discussed this is the continuous time signal. Now I divided the x-axis with a particular time interval capital T. So this distance is capital T, similarly this distance is capital T, and so on. So previously my signal was xt. Right now from the xt it will coming of the x of n into capital T, where t equals to sampling time interval and n is the time index. It is an integer, it varies minus infinity to infinity. From the xt to x of nt, the process is known as a sampling. So xt is the continuous time analog signal, x of nt is the discrete time signal. So I conclude in this way, continuous time signal are defined at all continuum of time, whereas discrete time signals are defined as discrete instance of time. So discrete time signal, time is the in discrete instance. Now previous slide I explained how the xt2 signal is coming for the x of nt, and this process is known as sampling. Now I divide here the amplitude axis with a particular step size, and from the x of nt to signal is become xq_nt, and this process is known as in quantization. Now after xq_nt, the signal becomes discrete, that is x of n. Now I conclude the last two slides. From the xt, after sampling, the signal becomes x of nt, and process is sampling, and from the x of nt it will become the x cube nt, and process is known as a quantization. After x cube nt, after encoding, we can get the binary sequence. So xt is the continuous time signal, xnt is the discrete time signal, xqnt the discrete time signal, and after encoding, this is the digital signal. So after xqnt we getting the xn. So there is a difference between the discrete time and digital. What is the discrete sequence? That is that a particular interval of time I get the different amplitude value. So here the amplitude values are not fixed. But in the case of the digital, after a particular time interval, I get the amplitude value, and that is the fixed value. So this is the basic difference between the discrete and digital. So n is the time index, which I already discussed, and n is an integer and it varies minus infinity to plus infinity. Now I discuss in this slide the continuous and discrete time system. First, I explain what is the continuous time system. In continuous time system, if I feed the xt in a particular black box, or I say hardware, where the transformation is going on, and we get the yt, that is the output, and we can say output is nothing but the transform of the input, that is xt. So it is written the yt equals to transform of xt. Now in the discrete time system, if I feed xn in a particular black box where the transformation is going on, I get the output yn. Yn is the transform of xn. Now I explain in detail. A system is defined as unique transform convert one sequence xn called input to another sequence yn called output. When input and output both are the continuous, the system is also continuous. Otherwise, system is discrete. Means that when the input and output both are the discrete, system is discrete. Now, it is very important that the system is not necessarily the hardware box. It can be algorithm also. Now, there is several systems are there. That is a static and dynamic system, linear and nonlinear system, causal and non-causal system, time variant, time invariant system, stable and unstable system, FIR and IIR system. This course is basically designed for the MTech student. So these all the systems, static, dynamic, linear, non-linear, time variant, time invariant, they learned in the BTech course named as a signal and system. So we assume this is a prerequisite. So I am not explaining in detail the different kinds of system or different types of system. Now I come to the impulse response and convolution sum. Now if xn is the del n and I fed it to a black box where the transformation is going on, and I get the output yn, which is nothing but the transform of the del n, and we can get hn. Hn is known as the impulse response. That means if input is the del n, output is the hn, and hn is nothing but the transform of the input del n. Convolution between any input signal xn with a system having impulse response hn is given as xn convolute with hn equals to summation of k varies from minus infinity to infinity xk hn minus k, where this star denotes the convolution. This star basically denotes the convolution. So in this lecture, I discussed what is basic definition of the signal, what is dependent variable, what is independent variable, what is the one-dimensional signal, two-dimensional signal, three-dimensional signal, continuous time signal, discrete time signal, what is sampling, what is quantization. Next, I'll explain what is the difference between the discrete and digital. After that, I explain what is the continuous time system, what is the discrete time system. Then impulse response, and finally the convolution sum. So this is up to lecture 1. This is our contact details. My contact email address is the anileshday@ieee.org, and s_sannal@ieee.org. It is the Sannal sir's email ID. So feel free to write us if you have any doubt and query. This is the end of lecture 1. Meet you in lecture 2. Now finally, if you like, then please subscribe our YouTube channel.